All right, here we go. Lab 7, the mechanism of dihydroxylation. By this point, you should be familiar with all the alkene reaction. Have you seen any of this? Are you familiar with it? At least you have learned at least most of it, okay? Or some people yeah, have different lectures, so you probably have learned all this already, all right? Now, here's what we're gonna do, right? In all alkene reaction, I show just this for example. I would like to classify these alkene reactions based on the stereochemical outcome. And if I do that, I would get three groups. Okay, look at the product. Look at the stereochemistry of the products. All right. Now, in the first group, you can see that two hydrogen, two oxygen, oxygen and hydrogen, all these are added on alkene on the same side. All right, on the same side. In this case, we call this type of reaction syn addition. You might have heard this word before from the lecture. Okay, so we call this is syn addition. Now, move on to the second one. So, two X's, X and oxygen, two oxygen are added on the opposite side. One is up, the other one is down, up and down, up and down. See that? In this case, when the electrophile and the nucleophile are added on the opposite side on alkene, we call it an anti-addition. All right. And the last one, take a look. You've got mixture. We have syn addition. We have anti-addition. Syn and anti, they are mixture. I just call it mixed addition. Mixed addition. I don't really have a name for it. Okay. Anyway, so if you look at the stereochemical outcome of all reaction of alkenes, you can classify them into these three reactions. Now, the next question is, what controls the stereochemistry of each of these groups? Okay. So in the syn addition, something in the mechanism along this line make the reaction goes in addition. The nucleophile and electrophile are added on the same side, and somehow that also prevent this reaction to go anti-addition, and vice versa for anti-addition. Something control make the product go anti-addition, go to opposite side, yeah, and prevent that from go syn addition. And mixed addition, of course, there's nothing prevented. Okay, you got a mixture. All right, all right. Uh, the lab this week we're gonna look into syn and anti-addition, but before that, I'm going to walk you through, hey, what control the stereochemistry? Okay, why this goes syn, why this go anti, and at the end of the lab, when you do the lab this week, at the end of the lab, you have to propose the reasonable mechanism. I'm not saying the correct one. There are multiple proposed mechanisms that convincing. Okay, but first off, you need to know what control this stereochemical outcome. All right, let's take a look at the next video. We're gonna start with the syn addition. All right.